Good afternoon, welcome to a Workshop Wednesday, back on the tools. Today I'm going to build a 3-wood for you for one of our coach's fathers, so I better do a good job. Okay, so today's build is a Callaway Rogue ST Max 3-wood. 15 degree fixed hosel on this, so no sleeve setting change. And we are going to build this with a Mitsubishi C6 Blue 6. The markings you see here denote the flex rating. As you can see, many manufacturers are moving away from actually using the terms regular, stiff and X because it has very little bearing on performance. It's mainly about shaft weight. So in recognition of this, shaft manufacturers don't want you to see a regular or a stiff and be concerned that the shaft is too soft or too stiff. So 2 notches here for Mitsubishi denotes regular, 3 would be stiff, and 4 would be X. The fitter's recommendations for this spec is to play at 42¼ inches long, a swing weight of D2, and that's with a Golf Pride tall velvet mid-size grip, and at a playing frequency of as close to 4.0 as possible, and we'll show you how we get onto that shortly. Right, first things first is we want to test the frequency of this shaft with this head at that length to see if we need to tip the shaft at all. My guessing is we are going to need to tip the shaft a little bit. For a 3-wood, I wouldn't want to tip it any more than 1¼ inch, 1.5 very, very max, because then you start to lose the tip section of the shaft. And in this particular shaft, we've got an ingredient called titanium nickel fibers. So really, we want to keep the tip as active as possible. Okay, I first need a little bit of shaft bag. I try and find okay, so that's fitting nice and securely. I am then going to mark 42¼ inches. But for the purpose of using our frequency machine, I need to use take an extra 3 inches for the 3-inch clamp we're using. Now it's a pneumatic clamp at 100 psi. So I'm just going to insert the shaft into the clamp, lock it in place, and agitate the tip of the shaft. Okay, I'm going to say 230 CPM. If we then move over to our frequency chart. And Matt, if we look at the screen, I'm going to pop in 42¼ inches, and we said, say 230 yields a frequency of 2.4. Now we want as close to 4.0 as possible. I'm going to tip this shaft 1 inch, and then we're going to re-frequency it. But my guess is if I tip it 1 inch, with a 60-gram shaft, it's going to jump up approximately 6 CPM. So let's go ahead and do that now. Pop the safety specs on and dust extractor. Measuring 1 inch. Just square off the tip of the shaft. And I'm going to repeat the test one more time. Again, marking 42¼ inches, and then 1, 2, 3, purely for measuring the frequency. I'm just going to make just a little cross on that one so I can identify which one it is against the others. So again, doing the same test, clamping at 100 psi. Okay, this has jumped up to 135. $137. So in its strongest plane, we're getting to around about 137. Yeah, that's... I'm just going to double check the spec again. If I can find it. Here we go. Make sure there's any other notes about the customer. Okay, so I'm actually going to take another 1/4 inch off and leave it as it is. So frequency-wise, we're going to be looking at 3.1. Okay, it's a little bit under the target frequency, but for this particular customer, weight was more important than frequency. And as I said, I wouldn't want to tip it more than 1.5 inches because I then think it's going to affect the playing characteristics of the shaft. So just to ensure that I don't cut to the wrong line, I'm going to remove all the existing marks. And I say this from experience, I have done it before. So we know we've got one line to cut to on the shaft. We want it to play 3-wood length, not 9-wood length. So just going to take that last 1/4 inch off. Right, so that is the tip end of the shaft. We now need to look at, can we achieve that swing weight at that length with this particular head weight and this grip weight? Because you've got to weigh up both sides of the equation. After all, a golf club is a seesaw, and there's very, very specific values this club needs to be built to. 42¼ inches D2. With the tall velvet grip, 1 layer of tape. So we are going to check the current playing length. From experience, I know that I can get to within 1/4 inch of this playing length at that swing weight. So I'm going to cut it to 42¾ inch so we can dry assemble and guess the swing weights to see if we need to add any more weight. So I'm going to go straight in to cut it to 42¾ inches. So this is 1/2 inch longer than the build spec dictates. Placing the grip on the scale, and we've got a swing weight of C9.5 assembled. That's going to be just tipping over D0. We need D2, so automatically I'm now thinking, right, well, we've got to do one or two things. We've got to leave it longer or add weight. 42¼ is actually is a very specific length for 3-wood, so I do need to add weight to be able to get the length down and maintain swing weight. So I'm taking a 4.5 gram brass tip weight, pop it into the tip, head back on, and see where we are. D2.5, that's going to jump up to D3. So we've got the swing weight, but we're still 1/2 inch longer than standard. Now I need to think, maybe use a slightly heavier tip weight. So we have these rubber tungsten tip weights, which are a little bit heavier. I still have sufficient tip insertion, even using the full tip weight. As you can see here, there is a little tip on the end of that. Whilst it adds to the length, the size of it increases the head weight as well. So we're now at D4.5, but the tip weight has also added an additional 1/4 of an inch. So I'm going to leave the full tip weight in there, and I'm going to take it down to 42.5 inches and see where we are. Okay, so we're at 42.5 inches, D1.9, D2 on the nose. We're 1/4 inch longer. Now there comes a decision as to whether, what is more important. Is the 1/4 inch more important, or is the swing weight more important? I think assembled, with the weight of the ferrule and the glue, we're going to be very close to 42.25 inches, maybe give or take 1/8 of an inch, and that's a target swing weight figure of D2. So I'm happy with this. We're going to go straight into the puring process to align the shaft in its most stable orientation. And what we will then do is, knowing that we've tipped the shaft correctly, we've added sufficient weight, we can actually, once the club is assembled, cut it back down to swing weight from the butt end of the shaft. So we'll do that now. Right, okay. The very last thing I need to do is just prepare the paint on the tip. So we're just going to abrade the tip section of the shaft. Just taking it down to the graphite, it creates a far stronger bond. Had we not abraded the tip and just gone straight onto the glossy paint of the shaft, the strength of the bond would be significantly less. We have seen some clubs come into us in the past where the heads have come up where the steel or the graphite just hasn't been abraded, and it's no surprise that the head has failed. Right, moving on to the puring machine. If you've tuned into these videos before, you've seen that the puring machine finds the shaft's most stable orientation and aligns that with the target. We are going to hit start. And the chuck holds the shaft very much like a golfer's grip, so greater pressure to the rear and the front of the chuck. It's not constant pressure, it's trying to simulate that as much as possible. I'm going to pop a little bit of tape on the shaft for the marking process. Rotate the shaft to its logo up position, which will be its control position. Quickly pop in customer's name, the make of the shaft, which is a Mitsubishi C6 Blue 60. The shaft type is composite. It's an aftermarket shaft. The shaft flex is regular. This has no bearing on what it does to the shaft. It's purely for the SST report, should a customer want to review it. And it's going into a Callaway head. Right, hit next. It's a 3-wood. And the first part of this test, if you've seen these videos before, is the tip of the shaft will be deflected underneath this arm here, which is called a load cell. And as it rolls through its circumference, it's measuring the force change in the upward position, upward direction. And it'll plot that, if you look on the graph here. What we can see here is, it may disappear, oh no, it's staying on. If this shaft was perfectly round and straight and completely uniform in bending properties, that load would be constant and that graph would be a flat line. As you can see here, we have a crest and a trough. Now, the pure orientation is going to be somewhere just to the left of this crest, where the oscillations will be as neutral as possible, very much like balancing a car wheel. Alloys and tyres are incredibly well-made components, but when they go together, they do need balancing, and it's no difference to a golf shaft. Just popping a tip mass on the shaft, which simulates a club head. And the first part of the test in the logo up position will be to see where we are now and where the shaft will be performing once it's been pured. And you can see it's really starting to pull across plane now. And if we look on the screen, Matty, we can see that's the pattern of motion detected by those two lasers pointing on the top of the tip mass. And as the shaft rotates by very, very small increments, that vertical movement, which they call vertical deviation, is slowly starting to squeeze and narrow. So the shaft is travelling back and forth in a much more stable and consistent fashion. This technology is appropriate for golfers of all abilities. Better players can feel a shaft working across the face. Players with a higher handicap or less feel can't make a compensation for something they can't feel. Therefore, one might say that actually puring shaft is more important for those who just want to swing the club and not have to worry about anything that may be a shot chip that may be shaft inducing. So the shaft will keep on being tested until that vertical deviation doesn't improve anymore. Actually, when it starts to get worse, which is done now, the machine will say, this is the optimal position. It drops an ink line, which I just have to reinforce with a pen as the ink's a little bit dry. The shaft did mark correctly, and we can see here that this is the before performance and this is the after. The analysis of this shaft is the shaft is rotated by 145.72 degrees from logo up, resulting in an improvement in out-of-plane oscillations by 94.67%. So we're very happy with that. I'm going to take the shaft out now, and we'll take it over to the bench for assembly. Okay. So once the club is set, we'll take a short recess until the adhesive is fully cured, and we can carry on with the final check and the gripping process. It's a two-part structural adhesive made by 3M, incredibly strong, 80% shear strength within 20 minutes, 100% shear strength in 24 hours, but after 20 minutes this club will actually be hittable. Mixing the two parts together, a little bit of dry sand to act as alignment beads to take out any play or sway in the shaft in the hosel. Okay, I'm going to drop the ferrule. Put a little bit of adhesive on the collar of the ferrule so the ferrule doesn't lift through impact, which it can do. I'm sure you've all seen ferrules lift. It's not the head coming off, it's just the ferrule lifting off the hosel because there's nothing keeping the ferrule stuck down. Then a little bit of adhesive on the inside of the ferrule, going all the way down into the bottom of the hosel, coating all the sides. We want to get as much contact as possible. To take our tip weight, coat the shaft of the tip weight, pop a very small amount of adhesive on the tip of the shaft, tip weight goes in. Again, we're trying to use as little adhesive as we can. And now we take the tip of the shaft, and when you hear that pop, that's the bubbles travelling from the hosel up into the shaft. The very last bit is I'm going to close one eye, use my dominant eye, and align the shaft so that alignment mark is at 12 o'clock in the hosel. Okay, remove any excess adhesive. Set the club down, look at my watch, and we'll come back to it in 10 minutes. Right, we are back. The adhesive is nice and set. That is absolutely rock solid. So we know we can safely handle the club now. Popping the shaft straight back onto the scales, we are seeing a swing weight of D3. The current playing length is 42 and it's just under 42 and a half. So I know that really I've got 3/16 of an inch to play with to see how we fare with swing weight versus length. I'm comfortable that I can take this down by 1/8 of an inch, and we'll do that now. Bearing in mind we've only got one tape layer going on as well, which won't change swing weight at all. Straight back onto the swing weight scale. And we are D2.4, D2.5. Now I'm happy with that because, believe it or not, the cellophane on this head will contribute to swing weight. Actually, let me take that off now and show you exactly what that's done. What will you give me? D2.1? Perfect. Let's move over to the gripping station. And it's just one tape layer on here, so I hold the top of the shaft in line with the white circles at the top of the grip, and then my thumb with the white circles at the bottom. Take one layer and wrap with my palm to ensure there's no creases or bubbles. Twist the tape at the top. Align the face of the fairway at 12 o'clock. Finger on the bottom of the grip to stop the solution coming out. A little bit of solution in the top of the grip. Give it a shake. Pour the excess down the tape and slide the grip on. Being careful to jump out the way of any grip solution. Wipe the excess from the top and the bottom of the grip. Okay, Matty, if you just back up a bit, I can... So we're looking to align the Golf Pride logo straight down the shaft, making sure that the little white notch at the bottom of the grip and the top of the grip is also aligned, and also that the pattern is symmetrical down the shaft. Very last thing to do is to turn the ferrule. So that the fit of the ferrule is slightly large for the hosel. This is intentional. This allows you to, we call it turning the ferrule, which is basically just shaving plastic off so there's a nice seamless connection between the top of the hosel and the ferrule. And all we do is we rotate the ferrule in the opposite direction to the turning belt. So we have a matte finish there. To get rid of the matte finish, we take a tiny bit of paper with a small splash of acetone. To give that ferrule a lovely glossy shine. Finally, we'll take the SST tape off, and I'm going to pop the club just back on the scales for the last time, just to double check the swing weight. We should be pretty much spot on. D2.0, which, believe it or not, I may have made it look simple, but it is actually quite a hard thing to balance head weight, shaft weight, length, frequency, and grip weight. So for anybody watching that thinks that a head and shaft recommendation is sufficient for a club to work, please do think again, and hopefully this video has showed you that it is actually quite a complex process, that the build side of the fitting is just as important as the fit itself. A poor build is a poor reflection of a good fit. So make sure whoever you go and see to be fitted, that they undertake the build. That way they can guarantee the club's been built spot on with the recommendations and guarantee performance. So if you've liked this video, please hit the subscribe button and the like button, and hopefully you'll join us on our next Workshop Wednesday.